All right, so I'm ready to look at example number 2, which in this case actually gives me two functions, and it's wanting me to find the volume of the solid of revolution between the where the region is defined by f of x equals x times 5 minus x, and g of x equals 8 minus x times 5 minus x. And so notice again here we're going to be distributing this x times 5 minus x just as we would here. But notice again we're still revolving about the y-axis, and so what I'm going to do again, first things first, draw the region. So what I went ahead and did was I went ahead and picked both of those graphs and plugged in the numbers to see what happens. I'm going to try to draw them in a couple of different colors. Let's see. This f of x equals x times 5 minus x. I'm going to go ahead and draw that in red. If you plug in 0, you get 0. If you plug in 1, you get 4. It's a nice big parabola coming up. Plug in 2, you get 6. At 3, you also get 6. And it's going to start coming back down. At 4, it's 4. And at 5, it's 0. If I were to look at 2.5, that's the peak of it. That its vertex, which is about 6 1/4. Not such a big deal in this question. I just kind of want to, again, get an idea what this looks like. So there's the first one. Let me go ahead. Actually, I'll label that just so I don't forget about it later. That's f of x equals x times 5 minus x. So let me go ahead and draw the other one while I'm at it. That one starts at 0, 8. And I know you guys don't have 8 on your graph, but that's not going to be such a big deal in this question. If I look at 1, you get 4. So there's an intersection right there. If I look at 2, I get 2. If I plug in 3, I also get 2. Notice the symmetry there. So it's going to start going back up. At 4, you get 4 as well. So there's the other intersection. At 5, you get 8. This parabola's vertex is at 2.5, and it happens to be at 1.75. So there we go. There's what my parabola is going to start looking like. So there we go. There is the region between f of x and g of x minus x times 5 minus x. All right, so essentially what I'm looking at here is this nice, pretty, kind of oblong shape where it's almost an oval, but it's got a little bit pointy ends to it at the intersections. And what's going to happen is this shape is going to get rotated around the y-axis. So we're going to have something that looks kind of similar over here on this side as well. Again, I'm not the perfect artist, but it's going to look kind of like this, where it's been rotated all the way around. So it's going to be almost a donut, but it's a little bit pointy on the ends and on the inside. It's got, I guess I would call it a bit of a rim to it on these edges. So yeah, it's going to look a bit like a donut. In this case, this would be a good method to try using the washer method as opposed to disc method. But here's, again, the problem. In this case, what I would end up having to do if I were to try to do the washer method would be I would have to change these into y's. And that's not so much something that I really want to do in this case. Again, because what's going to happen is, and I'll kind of sketch this for you real fast. If I were to try to make a washer, let's say right about here, what I would end up doing is actually using the same function twice at 2 different y values, which wouldn't be particularly helpful. It would actually be very, very difficult to try to, because I would have to actually split it here, and it just wouldn't work very well in the washer method. Just again, because I don't want to have to switch these to y's, and again, it's going to be difficult because the same function on both sides, on the far right and on the far left, it's actually the same function both times. So this is another good candidate for the volume by shells method. Now I will go ahead and mention there are some problems where you could literally do either one of them and it wouldn't particularly matter. But I'm trying to pick questions that are really and truly good candidates for having to do the volume by shells, because discs and washers just would not be easy to do. And so here's what I'm going to go ahead and do. I'm going to go ahead and look at this again. And so in this case, hopefully you guys are picking up on the fact that in this case, my x's are still my radius. Because I'm still looking, here's my axis of revolution. My radius is going to come out this way. So my x's are going to be the radius. I'm going to go from 1 to 4 because that's my my intersections. So let me go ahead and write all this down. So again, we're going from 1 to 4. Our 2 pi, our radius again is x. And so now what I need to do is figure out the height of these so-called cylinders. So what I'm going to do is I'm going to treat this like I would the area of a region problem, where I take the top one and I subtract the bottom one from it. So that's why this one's a little bit different. So notice the top one here is the red function, which is this x times 5 minus x. And again, we're going to treat this like a region between two curves. So I'm going to subtract this other function, 8 minus x times 5 minus x. And I'm going to go ahead and treat all of that together and go ahead and try to solve it. Again, this 2 pi is a constant. It can just come out. It's not such a big deal. I'm going to switch colors real fast so I can keep working. And what I'm going to go ahead and do is distribute stuff in here to try to make my life easier. So take the 2 pi out. I'm going to leave that x alone for just a minute, just because it's going to be a little bit easier to write down my work over here. So x times 5 makes 5x, minus x times x makes x squared. I'm also going to go ahead and just kind of work this out. I've got minus 5x plus x squared, and then I'm going to end up making all of that stuff negative just to try to make my life easy. So I'm still leaving that x out. So 5x minus x squared minus 8 plus 5x minus x squared. See, lots of things to combine in here. So 2 pi from 1 to 4. I'm going to leave that x out again, just so I'm showing all my work. 5x and 5x makes 10x. I'm going to have 2 negative x squareds here, and I'm still going to have a minus 8. Now I'll go ahead and distribute the x just to make my life easier. So that's negative 2x cubed. That's plus 10x squared minus 8x dx. Then I'm going to go ahead and integrate that. 2 pi, and don't forget to evaluate from 1 to 4. So actually we'll have to do a subtraction part here. So that's going to become x to the 4th. So I'm going to divide by 4, which leaves me with negative 1 over 2. That's going to become x cubed. So that's going to be 10 over x cubed, or it's going to be 10x cubed over 3. That's going to become an x squared. So I'm going to divide by 2, which just makes that a 4x squared. I'm getting ready to need my calculator here in a second. I'm going to go ahead and work this out over here so I can kind of save my room. So I've got 2 pi times, and I'll write this out, negative 1/2 times 4 to the 4th plus 10 times 4 cubed over 3 minus 4 times 4 squared. That's not over anything, excuse me. And then I'm going to go ahead and put my parentheses here and subtract the 1 part from it. I'll just write it down below. So we're going to do negative 1/2 of 1 to the 4th plus 10 times 1 cubed over 3 minus 4 times 1. And all of that is going to go together. All right, so I'm just going to type that all into my calculator real fast. So negative 1/2 times 4 to the 4th plus 10 times 4 to the 3rd over 3 minus 4 times 4 squared. And then I'm going to subtract the rest of that stuff. So negative 1/2. I'm not going to write the 1/4 or 1 to the 4th because that's just going to be 1. 10/3, again, 1 cubed is just 1, minus 4. That saves me some time in the calculation phase. And so what I got after I did all of that stuff together, the calculator actually gave me, and I'll write it over here, I've got 2 pi times 43 over 2. So the 2's are going to cancel out. My final answer is going to be 43 pi. Okay, so notice again, good candidate here for the for the shell method. And so what I did was I did 2 pi times my radius, in this case was x. My height of my cylinder was the top function minus the bottom function. And then I did all that algebra stuff, integrated, and boom, got my answer. Hopefully that does, again, help you understand this a little bit better. I'm going to come back in the next video and compare methods so that we kind of get an idea of when to use what. And then I'll do one more example.